Good morning, friends. Welcome to the another session of NEET 2022 Smart Crack series. And in this session, we are going to talk about work, energy, and power. So, we'll cover work, energy, and power in one shot. Okay. So, let's begin. So, we have studied about the work, energy, and power in 11th standard. Let us recall it. So, let's suppose we have this force F bar. Okay, and it displaces this block along this horizontal surface, okay, in this direction. All right, so now F bar is the force, S bar is the displacement. So I want to find out how much would be the work done in this displacement. So how much would be the work done? So if theta is the angle between force and displacement, then we write work done equals to, if force was in one dimension and displacement was in also the same direction, okay, force and displacement both are in same direction, then work done can be simply represented as work equals to force into displacement. Now the directions of force and displacement are different, so how do we write it? It is dot product of force and displacement. And what do we mean by dot product? So dot product is the scalar product, okay, between two quantities. So it is scalar product between force and displacement here. Okay, so now if I resolve this force along two perpendicular components, so there will be one horizontal component, let's call it fx. There is one vertical component, let's call it fy. So which of these two components is doing the work? So clearly there is no displacement along vertical direction, there is only displacement along the horizontal direction. So vertical component is not doing any work and it's only the horizontal component that's doing work. Okay, so we can write that work done is equal to this horizontal component multiplied by displacement, magnitude of displacement. And that is equal to what? What is horizontal component? So it is f into cos of theta, right? Okay, so this gives us definition of the dot product between two vectors, or which we call scalar product also. Samina Pavil, how much questions are expected from this lesson for NEET, sir? Okay, so one question will definitely be there. Okay, so it's 1 to 2 questions. All right, so work done is equal to what? F into S into cos of theta, and which we have written as dot product between these two vectors, force and displacement. So this gives us definition for the dot product or the scalar product of two vectors. What is scalar product? When you multiply two vectors and resultant is a scalar quantity. So it is F bar dot S bar is equal to what? Magnitude of force into magnitude of displacement multiplied by the cos of angle between two. So now this is work done by a constant force. Okay, so now let's suppose I have two vectors, a bar, which is ax into I cap plus ay times j cap plus az into k cap, and another vector b bar is bx into I cap plus by times j cap plus bz times k cap, and suppose c is equal to a bar dot b bar. Then what is dot product? It is the product, okay, it is magnitude of first vector multiplied by magnitude of second vector multiplied by cos of the angle between two. So when you will multiply a bar and b bar, so a bar is ax into I cap plus ay into j cap plus az into k cap. Similarly, b bar is written in same format. So when you multiply these two, what happens is I dot j equals to 0. Similarly, you can say j cap dot k cap, and it's also equal to what? K cap dot I cap. Okay, so the product of any two perpendicular vectors is equal to 0, and it gives us I cap dot j cap. So unit vector along x-axis multiplied by unit vector along y-axis, it is equal to 0. Similarly, j cap dot k cap is equal to 0 and k cap dot I cap is equal to 0. Yes, good morning, Dev. So, and it also gives us I cap dot I cap equals to j cap dot j cap equals to k cap dot k cap, and this is equal to 1. So if we use this, okay, what do we get? We get C equals to ax bx plus ay by plus az bz. All right. So this is the definition of dot product of two vectors. Okay. All right. So now let's move on to another concept, the work done due to a variable force. Okay. Now we know about the scalar product. So what will be work done due to a variable force? Work done due to a constant force is just what? Component of force in direction of displacement. Okay, F cos theta multiplied by displacement. So now we are going to one dimensional case again. So here this force is function of the position. Okay, so it is not constant everywhere. All right, it is changing. So in this case, what will happen? So if you think about the work, so let's suppose I consider about this much displacement, let's call it delta x. So force over here is f of x, okay, and this is f of, here it will be f of x plus delta x. So approximately the work will be equal to what? So if you draw a rectangle like this, so approximately it will be area under this rectangle. Okay, the work done from this position to this position. So if you add all such areas, what will you get? You will get what? The integration. Okay. So for one area, I can say it will be f at x dot delta x. If you add all such areas, what will you get? You will get area under this curve, and we know how to represent area under a curve. So area under a curve is represented by an integration. Okay. So it is f of x dx. Okay. So let's suppose you want to find out work done from x1 to x2. It will be area under force versus position curve from x1 to x2. Okay. So this is what? This is area under f x curve from x1 to x2. Okay. That is force due to variable, work due to variable force. Okay. After that comes the concept of potential energy. So what is potential energy? So it is energy possessed by a body due to its position or configuration. All right. So for an example, the gravitational potential energy, we know that it depends on the height. Okay. So it's equal to what? mgh. Okay. If height is small. Now, potential energy can be also written as the work done against conservative forces. Okay. So work done against the conservative forces gets stored as the potential energy of the system. So what is a conservative force? So now if you think about a force, okay, let's suppose you think about gravity, then you have some object over here at this point, and you move this object from this point to some other point. You move it, suppose here, okay, at this point. So it does not matter along which path you move this object. So if you move the object like this, there will be some work done. Let's call it path 1. Okay, you move it like this. This is suppose part 2. and you move it something like this. This is suppose path 3. Okay, so work done against gravity along path 1 is suppose W1, work done along path 2 is W2, work done along path 3 is W3. So to move this block from here to here against the gravitational force, the work that has to be done will be equal along all paths. Okay, so work done along path 1 equals to work done along path 2 equals to work done along path 3. Then we call that force as a conservative force. Okay, yeah, good morning Bhagyashree. So this is another definition of potential energy, work done against the conservative force. What is conservative force? The force for which work done does not depend on the path followed. Work done by that force or work done against that force doesn't depend on the path followed is known as conservative force. So work done against such a force gets stored as potential energy of the system. For an example, gravitational force, electrostatic force, then the spring force. Okay, so if you have a spring block system like this is a block at this position O, and you move it from this position, let's say 0 to X, then you have to do some work against the spring force, because spring force will try to restore it back to the position, its original position, that's 0, and you want to move it away. Okay, so you have to work against the spring force. So how much will be the work against spring force? So because we are doing work against the force, there will be this negative sign, and this is the spring force. Okay, so this is spring force minus kx. So integral from 0 to x spring force dot dx will give you what? Work done by the spring force. But you want work done against the spring force, that's why you are putting this negative sign. And it gives us what? It gives us half of k into x square. Okay, so this is potential energy of a spring block system. Okay, when it is at position x away from its equilibrium position. What is equilibrium position? The position where force acting on it is 0. Alright, this is simple. So what is potential energy? Energy possessed by a body due to its position or configuration. Then what is kinetic energy? So kinetic energy is the energy possessed by a body due to its motion. Okay, then comes work energy theorem. What is work energy theorem? So work done by all forces. All forces means conservative forces as well as non-conservative forces. So work done by all the forces on a body or a system, it's equal to what? The change in kinetic energy of that system. Okay, this is work energy theorem. Then comes the principle of conservation of mechanical energy. So what is mechanical energy? It is sum of potential energy and kinetic energy of a system. Okay, so principle of conservation of mechanical energy says that in presence of the conservative forces only, that means if there are non-conservative forces, then this will not be followed. Okay, so in presence of conservative forces only, the total mechanical energy of the system gets conserved. So what is mechanical energy? It is potential energy plus kinetic energy. Okay, so sum of potential energy plus kinetic energy remains constant. Alright, this is conservation of mechanical energy, and it is applicable when and only when there are only conservative forces acting on a body or a system. After that comes the concept of power. What is power? It is the rate at which work is done. Okay, so power is defined as work done divided by time taken. If work is done in at a constant rate, and it can be written as, if you want instantaneous power, okay, average power will be work done upon time taken. If you want instantaneous power, then it is derivative of work with respect to time. Okay, the rate of doing work with respect to time. So it is derivative of f bar dot s bar, because work done is equal to what? force into displacement, dot product of the force and displacement. So if you take this derivative, what will you get? If force is constant, then you can take the force outside of the derivative, and it's equal to F bar dot ds bar by dt. What is ds bar by dt? It is change in position with respect to time. Okay, or you can say it is displacement with respect to time, so it is velocity. So this is another formula for power. The instantaneous power is equal to what? It is dot product of force and velocity. Okay, this is instantaneous power. All right, so this is the concept of power. After that, you apply the conservation of energy to vertical circular motion. And what is vertical circular motion? It's motion of an object along a vertical circular path. Okay, so this is your object which is performing vertical circular motion. It can be a stone or a ball tied to a string and whirled in a vertical circle. So what is its minimum speed? So its minimum speed will be at this topmost point, okay, at the highest point, okay, and minimum speed at the topmost point will be equal to square root of gr. Okay, this happens when tension in the string is equal to 0 at this point. Okay, it moves at minimum possible centripetal force. Okay, so at highest point the minimum speed is square root of gr. At the lowest point the minimum speed is square root of 5 gr, and at the midway point here it is square root of 3 gr. All right, and what about the tension? So tension in the string at the topmost point is equal to 0. The minimum tension is 0. If it is moving, if this ball is moving with the minimum speed, the tension over here will be equal to 0 at the midway point. So tension over here will be equal to what? 3 mg, and at this point the tension will be equal to 6 mg. All right. After that, let's talk about collisions. So this is an important topic from this chapter. Collisions is an important topic. So in recent years, the questions have been asked only on collisions. Okay. So more often than not, the questions are asked on collisions. Okay. So first concept is coefficient of restitution. Okay. So let's suppose we have these two bodies. Okay, m2 is mass of the second body, m1 is mass of first body. They are moving with speeds u1 and u2. First one is moving with speed u1, second one is moving with speed u2. Then when this first body hits on the second body, what will happen? There will be change in their speeds. So after collision, suppose speed of first body becomes v1 and speed of second body becomes v2. All right. So coefficient of restitution is v2 minus v1, v2 minus v1, it is velocity of separation, divided by u1 minus u2. Okay, what is u1 minus u2? It is known as velocity of approach. Okay, so relative velocity between the body which is following and the body which is being followed before collision, it is known as velocity of approach. Okay, and the relative velocity between these two bodies after the collision, it is known as the velocity of separation. So velocity of separation is v2 minus v1, that is the velocity with which the second body is being separated from first body. And what is velocity of approach? So it is u1 minus u2, it's the velocity with which first body is approaching second body for collision. Okay, so there are two types of collisions. First one is known as the elastic collision and the second one is known as inelastic collision. So what is elastic collision? In case of elastic collision, the momentum as well as the kinetic energy of the system of two bodies or n number of bodies, it remains conserved. Okay, what are the two quantities that remain conserved? The momentum and the kinetic energy. And in case of inelastic collision, what will happen? Momentum will still be conserved, but kinetic energy will not be conserved. Okay, so since momentum is conserved, I can write total momentum before collision equals to total momentum after the collision. So m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. After that, since kinetic energy is conserved, I can write kinetic energy of first body plus kinetic energy of second body before collision is equal to kinetic energy of first body plus kinetic energy of second body after the collision. Okay, so for the case of elastic collision, there is long derivation. If you solve it, you will get final velocity of first body and final velocity of second body. So these are those two formulae. We need to memorize them. So what is final velocity of first body? So it is m1 minus m2 divided by m1 plus m2 multiplied by u1. What is u1? The initial velocity of first body plus 2 times of m2 divided by m1 plus m2 into u2. Okay, and what is the final velocity of second body? So it is 2 times m1 divided by m1 plus m2 into u1 plus it is m2 minus m1 divided by m1 plus m2 times u2. Okay, so now we can memorize these two formulae, but there is one trick. Okay, what is I'm sorry, what is the trick? So if you just change 1 to 2 and 2 to 1 in this first formula, you will get the second formula. Okay, so in principle you have to memorize only first formula. Okay, so check that. If you change 1 to 2 and 2 to 1, so this 1 you will change to 2, so v1 will become what? v2. Okay, u1 will become u2. Okay, so this 1 will change to 2, you will get m2 minus m1, right? And see that term is here, m2 minus m1 times u2, because 1 you will change to 2, so times u2 plus you have here 2 times of m2. Now you have to change m2 to m1. Okay, so 2 times of m1 divided by m1 plus m2 times u2, you will change to what? u1. Okay, then you get this formula. So if you change 1 to 2 and 2 to 1, okay, you will get second formula from the first, or first formula from the second. All right, so that's about it. Now there are some special cases. So special cases are if m1 is equal to m2 in case of elastic collision, if masses of two colliding bodies are equal, then what happens? Then what happens is the velocities of those two bodies just get exchanged. Okay, so the final velocity of first body will be equal to the initial velocity of second body, so v1 equals to u2, and final velocity of second body equals to initial velocity of first body. Okay, so this happens when m1 is equal to what? m2. All right, and then if u2 is equal to 0, so what do we mean by u2 equals to 0? One body, this body is at rest, and another body comes from behind and it hits it. Okay, so if u2 is equal to 0, what do you have to do? You just have to substitute u2 equals to 0 in these two terms. So these two terms will not come. So what will happen? v1 will be equal to this first term, m1 minus m2 upon m1 plus m2 multiplied by u1. Okay, m1 minus m2 upon m1 plus m2 times u1. And v2 will be equal to 2 times of m1 upon m1 plus m2 times u1, because u2 is equal to 0. Okay, so these are the things that we need to remember in case of elastic collision. So what about inelastic collision? So for inelastic collision, some kinetic energy is lost. So what remains conserved? The momentum remains conserved. Okay, so total momentum before collision is m1 u1 plus m2 u2 is equal to total momentum after the collision, which is m1 v1 plus m2 v2. Okay, and then we know the coefficient of restitution, so it is v2 minus v1 divided by u1 minus u2. All right, so v1 is given by this formula. I don't tend to memorize this formula. So I don't prefer to memorize. If you want, you can memorize it. Okay, because very often there won't be direct questions on this formula. Okay, there is very rare chance. All right. So V1 equals to M1 minus E times M2 multiplied by U1 plus 1 plus E M2 times U2 divided by M1 plus M2. And V2 is given by M2 minus E times M1 times U2 plus 1 plus E M1 U1 divided by M1 plus M2. Okay. Now after that, for a perfectly inelastic collision, what happens is E becomes equal to 0. So what does it mean when E becomes equal to 0? Velocity of separation is 0. Okay, if velocity of separation is 0, that means bodies don't separate after the collision. So they stick together and move together. Okay, so in that case, what happens? If E is equal to 0, this formula gets simplified somewhat. So we get V1 equals to M1 U1 plus M2 U2 divided by M1 plus M2. And V2 is also same. So it is M1 U1 plus M2 U2 divided by M1 plus M2. Alright. So for perfectly inelastic collision, E is equal to 0. Coefficient of restitution is 0. Bodies don't separate. They stick together and move together. Alright. Then you get these formulae for the velocities. Okay. Basically, velocities of both bodies will be same because they stick together and move together. What will be that velocity? M1 U1 plus M2 U2 divided by M1 plus M2. Alright. So this is all for theory for this chapter. And now let's move on to the problems. Let's solve some problems. Alright. So let's look at first problem. A particle moves so that its position vector is given by this thing. R bar equals to cos omega t multiplied by x cap plus sin omega t multiplied by y cap, where omega is constant. Which of the following is true? Okay, so now I will tell you one thing. So this is the position vector for a particle performing circular motion with angular velocity omega. Okay, so let's see the options. Velocity is perpendicular to r and acceleration is directed towards the origin. So this is the case actually for the case of circular motion. Okay, velocity is perpendicular to r and acceleration is directed towards the origin. We know in circular motion the velocity is along tangent. Okay, so this is r, this is v, they are perpendicular to each other, and acceleration is centripetal acceleration, which is directed along radius and towards the center. So without even solving this, we know that option A is the answer. But if you don't know that, then you will have to solve. So let's see how to solve. So how to find velocity? What is velocity? It is rate of change of position vector with respect to time. Okay, that is d by dt of cos of omega t multiplied by x cap plus sine of omega t multiplied by y cap. So here we have to use the chain rule of derivatives. So what is chain rule? If you don't know, the chain rule is, let's suppose you want to find out coefficient of, so let's suppose you want to find out derivative of one vector r with respect to t. Okay, but r is suppose function of some other. Okay, so let's suppose you want to find out derivative of this quantity r with respect to t, and suppose r is function of u, r is not directly function of t, then how will you find derivative? So derivative of r with respect to t can be written as dr by du multiplied by du by dt. This is chain rule. Okay, and how to use that here? So here our u is omega t. Okay, so it is cos of omega t, sine of omega t. It's not directly t. It's not cos of t or sine of t. Okay, so let's find out derivative. So our u is equal to omega t. What will be du by dt? What will be du by dt? It will be, omega is constant, so it is just omega, right? Omega multiplied by dt you can say, but dt by dt is 1, so it is just omega. Okay, so I will write dr by dt, dr bar by dt is d by dt of, I will change this to cos of u into x cap plus sine of u into y cap, and then I can write it is derivative of cos u with respect to u. Okay, see, we are taking derivative with respect to u first, and then we are taking derivative of u with respect to t. So it is derivative with respect to u of cos of u multiplied by du by dt into x cap plus derivative of sine I'm sorry, sine u with respect to u multiplied by du by dt into y cap. Now take the derivative. What is derivative of cos u with respect to u? It will be minus sine u, right? So it is minus sine u multiplied by du by dt is omega into x cap plus, okay, you can write this as derivative of sine u with respect to t. It is cos of u multiplied by, what is du by dt? It is omega times y cap. So this is your velocity. Okay, and now you want to verify whether these two are perpendicular to each other. So how will you verify? This is a very lengthy problem. If you don't know that this is the position vector of a particle performing circular motion, in that case you can directly verify the answer. Okay, so if you don't know, then it's very lengthy problem. Okay, which you should not prefer to solve in NEET at that moment. It's okay. How will you verify whether R is perpendicular to V? So you take dot product of two vectors. Okay, so I am taking R in terms of u, I have written it. So it is cos u times x cap plus sine u times y cap. You take its dot product with minus sine u into omega times x cap plus cos u into omega times, sorry, I will just move it a little bit, plus sine u times omega into y cap. Okay, so now you multiply x component with x component. So what do you get? Cos u multiplied by minus sine u multiplied by omega. Okay, so minus sine u cos u into omega, and y component with y component. So you get sine u into, it was cos u over here. Okay, it was cos u, not sine u. Cos u. Okay, so what do you get if you multiply them? So you get minus sine u cos u into omega. Okay, and plus sine u into cos u into omega. So minus sine u into cos u omega plus minus cos u sine u into omega. Sorry, plus. Okay, so minus plus becomes cancelled out. It gets cancelled out, and therefore it's equal to 0. So if dot product of two vectors is 0, that means those two vectors are perpendicular to each other. Okay, so we have solved till this point. So let's check other options. So velocity is perpendicular to r and acceleration is directed away from origin. Okay. So in two options, it's there that velocity is perpendicular to r. So we have to investigate even further. Okay, if we don't know that r is the position vector of particle performing circular motion. Okay, if you know it, you directly get the answer. If you don't know, you have to solve this far. Okay, so let's find out acceleration. So what is acceleration? It is dv bar by dt, we know. Okay, and what is v? So v is given by this formula. Which one? This one. And omega can be taken out because it is a constant. So omega you will take out. It is d by dt of what's left? Minus sine u into x cap plus cos u into y cap. Minus sine u into x cap plus cos u into y cap. Take derivative. So what will you get? Omega multiplied by, it is d by dt of minus sine u, right? So I can write it as d by du of minus sine u into x cap multiplied by du by dt. What we are doing is we are applying the chain rule over here. Okay, plus it is d by dt derivative of this term, which is cos u into y cap multiplied by du by dt. Okay, after that, what is derivative of sine u? It is cos u. So from first term, what do you get? And du by dt is omega, and here also you have du by dt, that's omega. So omega can be taken out, so you get omega square. Okay, so 1 omega comes from here, du by dt. We have du by dt in both the terms. And what is du by dt? Because u is omega t, du by dt is omega. So you take that omega out, then you are left with only these derivatives. So what is derivative of minus sine u? Minus sign you can take out, its derivative of sine u with respect to u, it's minus cos of u. Okay, plus what is derivative of minus cos u? Sorry, what is derivative of cos u? It is minus sine u. So minus sine u, and we had x cap in multiplication of first term and y cap in multiplication of second term. So if you look at this, this is what is cos u into x cap plus sin u into y cap. So it is r bar. So this is equal to, if you take minus sign out, it is minus omega square into r bar. Okay, this is acceleration, and this gives you that acceleration is directed opposite to that of the radius vector. Okay, or r bar. All right. So if you don't know, you have to solve this part. If you know the formula, this formula, that this is the position vector of particle performing uniform circular motion, then you directly know the answer, that velocity is perpendicular to r and acceleration is directed towards the origin. Okay, so this is the answer of first question. It was laying the, yeah, Stranger's music. Yeah, good morning. All right, so let's move on to the next problem. Next problem is, if vectors a bar equals to cos of omega t into I cap plus sine of omega t into j cap, and b bar equals to cos of omega t by 2 into I cap plus sine of omega t by 2 into j cap are functions of time, then value of t at which they are orthogonal to each other. So we know that when two vectors are perpendicular to each other, their dot product is equal to 0. Okay, so we can use that. So a bar dot b bar should be equal to what? 0. So let's find out a bar dot b bar first. So it is cos of omega t into I cap plus sine of omega t into j cap dot cos of omega t by 2 into I cap plus sine of omega t by 2 into j cap. Okay, so let's perform this dot product. So it is first, the coefficient of I multiplied by coefficient of I. So it is cos of omega t into cos of omega t by 2 plus sine of omega t into sine of omega t by 2. Okay, so after that, this should be equal to 0 when two vectors are perpendicular to each other. Okay, they are perpendicular means their dot product is 0. Okay, what is dot product? It is magnitude of first vector into magnitude of second vector multiplied by cos of the angle between two. And cos of 90 is 0. Okay, that means when two vectors are perpendicular, the dot product must be 0. Okay, so cos omega t into cos of omega t by 2 plus sin omega t into sin of omega t by 2 is 0, and this is the formula for, let's say you have two angles A and B, and you want to find out cos of A minus B. Okay, then what's the formula? It is cos A cos B minus sin A sin B. All right, so what do you get? So here, if you look, it is cos of omega t into cos of omega t divided by 2 plus sin of omega t into sin of omega t by 2. Okay, it is cos A cos B plus sin A sin B if A is equal to omega t and B is equal to omega t by 2. Okay, so it is here A is equal to omega t and B is equal to omega t by 2. Then this thing is what? Cos of A minus B. Cos A cos B plus sin A sin B. And if you substitute that, you get cos of omega t minus omega t by 2 is equal to 0. Okay, so it is cos of omega t by 2 because omega t minus omega t by 2 is omega t by 2. So cos of omega t by 2 is equal to 0. That means this angle should be what? We know cos 0 is 1, cos 90 is 0. So this angle must be equal to 90 degrees. Okay, so what is 90 in radians? So omega t by 2 equals to 90 degrees, or you can say it is pi by 2, right? So this 2 and 2 gets cancelled because 2 pi equals to 360, pi equals to 180, so pi by 2 equals to 90. Okay, so this 2 and 2 gets cancelled and you get t equals to pi divided by omega. Okay, so option A is the answer. T equals to pi divided by omega. Right? Is it clear? Okay. So let's move on to the next problem. Consider a drop of rainwater having mass 1 gram falling from height of 1 kilometer. Okay. If it hits the ground with speed of 50 meters per second, then take g constant with value of 10 meters per second square. The work done by gravitational force and the resistive force is. So how much will be work done by the gravitational force? We have a mass of 1 gram. It is falling from height of 1 kilometer. Okay. Work done by gravitational force. Work done by gravitational force is equal to. It is mgh, right? mgh and it's equal to, how much is mass? It is 1 gram. So 1 into 10 raised to minus 3 in kilograms, multiplied by g equals to 10 multiplied by height is 1 kilometers. So 1 kilometers you can write it as what? 1000 meters. Okay. So mass is 1 gram, which can be written as 1 into 10 raised to minus 3 kilogram, and h is 1 kilometer, which is 1000 meters. Okay, so if you multiply this, this is 10 raised to 3, this is 10 raised to minus 3, it becomes what? 10 raised to 0, that's 1. 1 multiplied by 10, so 10. Okay, joules is the work done by gravity. Alright, so let's check the options. So option A, it is 1.25, option B is 100, option C is 10, and option D is minus 10. So option C is correct. You don't even have to solve for the second one. Alright, because it is falling, the drop of rain is falling, so motion is in direction of the gravitational force, and how much will be the work done? Work done equals to the change in potential energy, that is mgh. Okay, or you can say it is force into displacement. So gravitational force is mg, displacement is h. Okay, and you have found out that work done is 10 joules, so you don't have to solve that how much will be work done by resistive force by air. Okay, so it will be of course negative, and it is minus 8.75 joules. Okay, so this is how sometimes we have to use some smart tricks. You got the answer for first, and only first one option is matching with it, so you don't have to solve for the second. But in case you want to solve, how will you solve? So it's simple. It's falling with speed of 50 meters per second. Okay, so how much is change in kinetic energy? Okay, it's falling with the speed of 50 meters per second. So V equals to 50 meters per second. All right, but if an object falls from the height of how much? 1 kilometer, then how much should be its kinetic energy at this point? So K should be, it should be equal to potential energy at top. Okay, if there is no resistive force, so it should be equal to potential energy at top, and that is equal to what? mgh, that's 10 joules. But now what you will do is you will find out the kinetic energy at this point. So actual Ke is equal to what? It is half of m into v square, that is half of m is 1 into 10 raised to minus 3 into v square. V is 50, 50 square. Okay, that is 10 raised to minus 3. 50 square is 2500, right? So 2500 divided by 2 is how much? 1250. 1250, so it is 1.25 joules. Okay, after that what you will do is, how much was its total energy? It was 10 joules. So how much should be total energy at this point? If energy is not lost, it should be what? 10 joules. But how much is the actual energy? It is 1.25 joules. So how much is the energy lost? It is, what is the total energy? 10 joules minus this energy. Okay, so I will write energy lost is equal to what? Potential energy at height h, 10, minus kinetic energy at this point. Okay, so 10 minus the kinetic energy, and that is equal to 10 minus 1.25, and it comes out to be what? 10 minus 1 is 9. So 9 minus 0.25 is 8.75. Okay. So this much should be the work done by the resistive force. All right. The energy lost is the work done by the inner resistive force. So minus 8.75 is the work done by resistive force. This is how you can find it out. Okay. So it's simple. Any question? No questions? Let's move on. Okay. So next question is, a particle of mass 10 grams moves along a circle of radius 6.4 centimeters with a constant tangential acceleration. Tangential acceleration is constant. What is the magnitude of this acceleration if kinetic energy of particle becomes 8 into 10 raised to minus 4 joules by the end of second revolution after the beginning of motion? Okay, so the motion begins, its kinetic energy goes on increasing because there is tangential acceleration. Okay, so question is, what is the magnitude of this acceleration is the question. What is the magnitude of this acceleration if kinetic energy of particle becomes this much? So kinetic energy equals to what? It is 8 into 10 raised to minus 4 joules at the end of what? Second revolution. So in one revolution, it will cover some distance. How much will be distance? So distance covered in one revolution will be n times of 2 pi r. Distance covered in one revolution is 2 pi r. Distance covered in two revolutions will be 2 times of 2 pi r. Okay. So S is equal to 2 times of 2 pi r, that is 4 times of pi into r. Alright. So now you can use the law of conservation of energy. Okay. Or you can say work done is equal to kinetic energy, right? So how much will be the work done over here? So there is constant acceleration. A is the constant acceleration. Okay. There will be some mass m. Okay. So force is equal to that mass into acceleration. And what is displacement? It is change in position. Okay. It's the distance by which it moves, because acceleration is always tangential, right? So, and velocity or the movement is also tangential. So we can say work done here is equal to work done by the tangential force. So it is force into displacement, and it is equal to change in kinetic energy. So it is final kinetic energy minus the initial kinetic energy. So final kinetic energy is half of mv square. Initial kinetic energy is 0 because particle starts with 0 velocity. So it is m into a multiplied by the distance by which it moves. How much distance? 4 pi r along the tangential path. Okay, so now you want to find out acceleration. So you can take other things on the other side. So what do you get? Half of, okay, m gets cancelled. Half of v square divided by 4 pi r. Right. Now we can substitute the values. What are the values? So it is 8 into 10 raised to minus 4. Okay. So actually it is half of mv square. So we should not cancel m. Let's not cancel m. Let m be there because we don't have velocity. What do we have? We have kinetic energy. Okay. So let's keep m as it is and let's move. So this is kinetic energy, final kinetic energy. We have direct formula for that. So let's keep it as it is. Okay, this is final kinetic energy, and let's move m on the other side. All right, so m into 4 pi r I have moved on the other side. I am not substituting kinetic energy equals to half of mv square. I am keeping it as kf only. Okay, so we have kf, value of kf, it's 8 into 10 raised to minus 4 joules. So 8 into 10 raised to minus 4 joules divided by, how much is mass? Mass is 10 grams. Okay, so 10 into 10 raised to minus 3, and radius is 6.4 centimeters. Okay, so into 4 multiplied by pi, we have, which is 3.14 multiplied by, or let's keep pi equals to 22 by 7. This seems to be a lengthy calculation. Multiplied by, we have radius 6.4, right? So 6.4 into 10 raised to minus 2 in meters. So this 10 raised to minus 3 and 10 raised to minus 2 becomes 10 raised to minus 5. If we take it in numerator, it becomes 10 raised to plus 5. So 10 raised to plus 5 minus 4 is 10. So we have acceleration equals to 8 times 10 divided by, what else do we have? Okay, so this 10 was there. So 10 multiplied by, we have 4 into 22, and the 7 I will take into numerator. Okay, 7 from the 22 by 7, I will move it into the numerator. And what else is there? 4, 22 and 6.4. This 4 into 22 into 6.4. So this 10 gets cancelled. 8 divided by 4 gives me 2. Okay, so this 2 I will cancel out with 22, so it will be 11. So I am left with 7 divided by 11 into 6.4. Okay, so let's check what are the options. All right, so this 7 I will cancel out with 6.4. It will be somewhere around 1.2 or something. Okay, 1.2 or something, we can find it out. Divided by, I have 11. Okay, so what I have done is 7 divided by 6.4. So I'm guessing it will be somewhere close to 1.2, and I'm dividing that by 11, will be somewhere close to what? The point will shift. It will get shifted towards left. So it will be 0.1 something. Okay, and that should be my answer. It will not be as far as 0.18. Okay, because 0.18 is close to 0.2. It's closer to 0.1. So that's why that should be the answer. Okay, we can check that, we can find out, but this is how we have to guess, right? So that's the answer. And then let's move on to the next problem. So the next problem is, a particle moves from this point to this point. Okay, minus 2 I cap plus 5 j cap to 4 j cap plus 3 k cap when force of 4I plus 3j Newton is applied. How much work has been done by the force? This is what we have to find out. So we know what is work. Work equals to dot product of force and displacement. Okay, so it is force. How much is force? It is 4I cap plus 3j cap. So 4I cap plus 3j cap is the force. What is displacement? It is final position vector minus initial position vector. So I will write displacement is final position vector 4j cap plus 3k cap minus initial position vector is minus 2I cap plus 5j cap. Okay, it is final position vector minus the initial position vector. Then I have 4I cap plus 3j cap, its dot product with resultant of these two. So 4j cap, and there is 5j cap in another term. There is no I cap, so we can write it as minus of minus 2 I cap. That's plus 2 I cap. 2 I cap. So 2 I cap, then it is 4j cap minus 5j cap. So 4 minus 5 is minus 1. So minus j cap, and 3k cap, there is no k cap term on the other side in second term. So plus 3k cap. And then we have to multiply this. Okay, so all right. So 4i multiplied by 2i. How much is that? 8. Okay, I dot I is 1. So 4 times 2 is 8. Plus we have 3j minus 1j. Okay, multiplied by minus 1j. So 3 into minus 1 is minus 3. J times j is 1. Okay, so it's minus 3. And there is no k term over here. So there is no need of multiplication. Or you can say 0 k times 3k. Okay, so k times k is 1. K cap into k cap is 1. 0 into 3 is 0. Okay, so this gives us what? 8 minus 3. So it is 5. 5 joules is the answer. Okay, option C. So is it clear? It's simple, right? So here we are just doing dot product. We have force and displacement. Okay, work done is dot product of force and displacement. So force is given by this term 4i cap plus 3j cap. Okay, and what is displacement? It is final position vector, which is this one, minus the initial position vector. Okay, so this was a simple problem. Let's move on to the next one. Next one is a uniform force. I guess it's similar. 3i cap plus j cap Newton acts on a particle of mass 2 kg. Hence the particle is displaced from position, this position, let's call it R1, and to this position, let's call it R2. Okay, the work done by the force on the particle is exactly similar to the last problem. So what is work? Let's solve it once again. So what is work? It is dot product of force and displacement. So this is the force. Okay, so that is equal to dot product of force with final position vector minus the initial position vector. Okay, so force is 3i cap plus j cap dot displacement is r2 bar minus r1 bar. So what is r2 bar? It is 2i cap plus k cap. What is r1 bar? It is, oh no, r2 bar was this one, right? So r2 bar is 4i plus 3j minus k cap minus r1 bar is this one. Okay, so 2i cap plus k cap. Let's solve it. So here we have 3i cap plus j cap, that is force, and displacement is 4i minus 2i, that is 2i. 3j minus, there is no j term in r1 bar, so plus 3j minus k cap minus this k cap, so not minus minus k cap minus k cap, minus 2 k cap, right, minus 2 k cap. Okay, and then let's do multiplication. So 3i cap into 2i cap, so I cap dot I cap is 1, 3 times 2 is 6, 1 j cap plus plus 1 j cap into 3 j cap, so j cap dot j cap is also 1, so 1 times 2 is 2, so plus 2, and there is no k cap terms, so 0 k cap multiplied by minus 2 k cap, it is 0, so no need to add. Okay, so did I miss something? No, this 6 plus 3 times 2 is 6, and 1 times 3, oh, it is 1. 1 times 3 is 3. Where did I take the 2 from? It is 3. So 6 plus 3, it is 9 joules is the answer. Okay, so option C. Okay, here I had done silly mistake. I had multiplied 1 j cap into 3 j cap and I had written 2. It was 3. Okay, it has to be 3. So this is a simple problem. Force into displacement gives us work. Let's move on to the next one. So next problem is force F equals to 20 plus 10y acts on a particle in y direction, where force is in Newton and y is in meter. Work done by this force to move the particle from y equal to 0 to y equals to 1 meter is. So this is simple. This is one dimensional problem. Okay. So work done equals to what? It is, since this is variable force, work done is equal to integral of force into displacement. Okay. So integral of f dot dy. All right. Because displacement is in y direction. So from where to where? Let's say y1 to y2. Afterwards, we'll substitute the values. So y1 and y2, we can substitute it right now. It's 0 and 1. What is force? It is 20 plus 10y dy. Okay, and then we can multiply this dy with both the terms. So it is integral from 0 to 1 of 20 dy plus integral from 0 to 1 of 10y dy. All right, and then we can take 20 outside. What is integral of dy? It is y, right? Or shall I write it? 20 I am taking outside, integral of dy from 0 to 1 plus here I am taking 10 outside, so it is integral of y dy from 0 to 1, and then integral of dy is y. So work done equals to 20 into y, lower limit is 0, upper limit is 1, plus integral of y dy. So it is integral of y raised to 1 dy, right? So what is our formula? Integral of, let's say, y raised to n is equal to what? Y raised to n plus 1 upon n plus 1. So here n is equal to what? It's 1. So we have y raised to 1 plus 1 divided by 1 plus 1, and 1 plus 1 is 2. That is y raised to 2 plus 2. Sorry, it is y raised to 2 upon 2, because 1 plus 1 is 2. And we had this 10. So 10 will keep as it is, lower limit 0, upper limit 1. So let's substitute the limits now. So 20 multiplied by upper limit is 1, 1 minus 0. Okay, upper limit is 1. So let's put y equals to 1. Okay, so y equals to 1, it gives us 1 minus, then we put lower limit, y equals to 0. Okay, then we have 10 into y square upon 2. So 1 square upon 2 minus 0 square upon 2. 1 square is 1, right? So it's 1 by 2. 1 by 2 multiplied by 10 gives us what? 5. And from first term we get 20. So 20 times 1 is 20. Okay, because 1 minus 0 is 1. So 20 times 1 is 20 plus it is 10 times 1 by 2. So which is 5. Okay, so 20 plus 5 gives us 25, and 25 joule has to be the answer. This is the recent question from, okay, NEET 2019. Okay, 2 years back. Yeah, hi Mohammad Zubair. Good morning. Answer is B. Where in last question, I guess. Or when did you comment? 30, 30 J, 30 joule. You want to say? There is no 30 joule. No, it's 25 joules. Okay, in this question itself. Yeah, it's okay. It's 25 joules. All right. So this is again another simple problem. Work done on work done due to a variable force. Okay, this is another problem. It is similar to last problem, but here we have a graph. Okay, force on a particle moving in a straight line varies with distance d as shown in the figure. The work done on the particle during this displacement of 12 meters is. So can you tell me what will be work done? So we have seen, yeah, ask you a doubt. Yeah, Mohammed Zubair, you can ask your doubt. This type of question, okay. See, enough depends on, actually the definition of enough keeps on changing for the people. Okay, so what I'm doing is I'm solving last, let's say, about 15 years of questions. Okay, so yes, so I'm explaining the theory also at the beginning and I'm solving the questions. So what you should do is you should solve the questions. Okay, you should see this sessions, then you should go back and you should check whether you can solve the questions by yourself. Okay, if you are watching live with full attention how I'm solving the questions, then you should go back, solve the same questions. Okay, try to solve the same questions and also solve some more questions. And some more means how many more? At least 5 times more. Okay, on each chapter. So if I'm solving 20 questions, you should solve at least 100 questions. Then it will build up your confidence. Okay, good. So now I want to find out work done by this variable force. So how much will be the work done? So work done by a force is given by area under force versus position curve. Okay, this we have seen. This work done by a variable force, and it is the integral of f dot dx. Okay, that we solved in last problem. We have taken integral f dot dy because it was in y direction. So it is integral f dot dx. Okay, if it is in x direction, right? So here area under a curve we can easily find out. So we have this rectangle and a triangle. Area of this rectangle will be how much? Length times breadth. Okay, and this, let's say b1 and l. Okay, let's call it something else. Let's call it h. Okay, so area of this rectangle is l times b. L is 2, b is how much? 7 minus 3, 4, right? And for this triangle it is how much? Half of base, which is h, 12 minus 7 into height is 2. Okay, so it's very simple. So w equals to area under this curve from the given start position to end position. Because it's not given, so it should be area under the full curve. Okay, so it is L times B plus what? Half of base into height. Height is L. Okay, so that is L is 2, breadth for this rectangle is 7 minus 3, so that's 4, plus half of what is h? H is 12 minus 7, 5, times L is 2. So this 2 and 2 gets cancelled. Okay, 4 times 2 is 8. 8 plus 5 is how much? 13. So 13 joules should be the answer. Option D. Okay, so this was simple. All right. So homework is pick any book. Okay, any book, whatever book you are using for your NEET preparation, you should pick that and solve 100 questions on this topic. Okay, the topic that we cover at a stretch. You can of course take breaks and solve, but at least solve 100 questions. That's your homework. Good. You're the first person to ask me about the homework. Yeah. Next problem. A body of mass 4m, okay, 4m is lying in xy plane at rest. It suddenly explodes into three pieces. Two pieces each of mass m move perpendicular to each other with equal speeds v. The total kinetic energy generated due to explosion is. So we have a body of mass 4m. It explodes in three pieces. Two pieces each of mass m move perpendicular to each other with equal speeds. Equal speeds, and what are those equal speeds? V. Total kinetic energy generated due to the explosion. Okay, let's find it out. So we have two masses moving perpendicular to each other. Okay, so another mass should move in some other direction, let's say. So one mass moves along x-axis. So this mass m moves with speed v. This one moves, this mass is also m, it moves with speed v. Okay, so this is vi cap and this is v j cap, because it's moving along x-axis, this one moving along y-axis. Okay, and another mass, when there is explosion, this mass, it flies off in this direction. So this is mass 2m and it will have some velocity. Okay, let's call it something, velocity of mass 2m, v2m I'm calling it. Okay, so now law of conservation of momentum says that sum of all momenta should be equal to 0, because before the explosion the bomb is lying in the xy plane, it is at rest, right? So law of conservation of momentum, or I will just say conservation of momentum, gives us what? Sum of, I will write p1 bar, this is for this first, let's call this first body, this is second body, this is third body. So p1 bar plus p2 bar plus p3 bar should be equal to what? 0, because momentum before collision, sorry, explosion equals to momentum after the explosion. Okay, so what is momentum of this mass? This first mass, it is its mass multiplied by velocity. Velocity is v into I cap, because it's moving in x direction. Okay, so mv into I cap plus momentum of second one is mv into j cap, mass into velocity. So mv into j cap plus, what is momentum of this one? So its mass is 2m, velocity is v2m bar, and sum of all this should be equal to 0. Then I can move this term on the right hand side, so it will become what? Or I can cancel out m from here because it's there in all the terms. Okay, so it is vi plus vj equals to minus v2m into 2. I'm sorry, this 2. So you can take this 2 on the other side. What I have done is I have just moved this 2 times of v2m on the other side. v2m is what? It is velocity of mass 2m. Okay, then you can move the minus 2 on left hand side, so you get v2m equals to v by 2. Okay, you can take v common from this and you are moving this minus 2 on the other side, so you can write minus v by 2, v upon minus 2 I cap plus j cap. Okay, or let's write like this only. Oh, I'll write like this only. V2m bar is equal to, I'll take minus 2 on other side and divide. So it is minus v by 2 into I cap minus v by 2 into j cap. That's it. Okay. And then we want to find out what? We found out the velocity. We want total kinetic energy generated due to this explosion. So what is total kinetic energy? It is kinetic energy is half of m into v square for first body plus half of m into v square for second body plus half of, now third mass is 2m, it's not m, into v2m square. Okay, but what is v2m? It is speed of the third body and it is magnitude of this v2m bar. Okay, so let's find it out. What is magnitude v2m? It will be square root of v by 2 square plus v by 2 square, vx square plus vy square. Okay, v2m is equal to square root of v by 2 square or minus v by 2 square, it's one and same thing, v by 2 square. Okay, so v square by 4, this gives what? V square by 4 plus v square by 4, that is 2v square divided by 4. So square root of 2 times v square upon 4 or v square upon 2. So you can write it as, okay, I just want v of 2m square, no? So I need not find out this all. It is square root of this thing. That's right. So v of 2m square will be what? It will be v square upon 2. All right. Okay, we need not find out the square root. Okay, then let's substitute it over here. So what do we get? We get kinetic energy equals to half of m into v square plus half of m into v square plus this 2 and 2 gets cancelled. So it is m times v of 2m square, and we just found v of 2m square from here. It is v square upon 2. So it is half mv square plus half mv square plus half mv square. It is 3 times half mv square, or 3 by 2 mv square. So this should be the answer. So option B is your answer. Okay, it's simple. All right. Okay, let's move on to the next problem. And next problem is, an engine pumps water continuously through a hose. Water leaves the hose with velocity v, and m is the mass per unit length of the water jet. Okay, what is the rate at which kinetic energy is imparted to the water? All right, so there is a water hose like this, and water leaves through here, and what's given? What's given is m is mass per unit length. So if you take length equal to 1 unit, so this much length is suppose 1 unit. Okay, so how much will be mass of this water? So mass of this water is equal to m. Okay, and now what you have to find out is how much, what is the rate at which kinetic energy is imparted to the water. Okay, so rate at which kinetic energy is imparted. So kinetic energy is suppose K. So rate of K will be equal to what? It is derivative of kinetic energy with respect to time. Okay, that's derivative d by dt of m into v square, but something is given, the speed is constant over here, so you can take that out. Okay, speed is constant. I will write some other m. Okay, I will write capital M because we should not get confused. It's half of capital M into v square. Okay, I will take m, not m, I will take v square by 2 because it is constant over here. Okay, so v square by 2 I am taking outside. Then what do I want? I want dm by dt. Okay, so after that, so we know what is the rate at, sorry, we know what is the mass per unit length of the water jet, that we know. So what we can do is we can divide this by length and multiply by length. Okay, so what is dm by dt? I can write it as this is equal to dm by ds multiplied by ds by dt. Okay, so mass is variable of s, right? So dm by ds, it's given, it is equal to m. So mass per unit length that is being ejected, it is equal to m. This is given. And what is ds by dt? ds by dt is the velocity. So it is, this is equal to m into v. Okay, so first term is equal to m, this is v, so it is m into v. So we can substitute that here. So what do we get? We get v square upon 2 into m into v. So we get m by 2 v cube, right? See, since this is v square by 2, and what is dm by dt? It is m into v. So v square by 2 we have another v, then it will become v raised to 2 plus 1, that is v cube multiplied by m. So m by 2 v cube is the answer, or half of m into, not this one, half of m into v cube is the answer. Okay, so yes, this is the, yeah, this was simple problem. Let's move on to next one. Is there any question from this problem? If you have question, you can ask. Questions? No questions. No questions? All right. Let's move on to the next problem. Next problem is a shell of mass 200 gram is ejected from a gun of mass 4 kg by explosion that generates 1.05 kg of energy. The initial velocity of the shell is, okay. So there is a bullet or shell that is being ejected from a gun. So let's suppose m is mass of shell, it is given 200 gram, okay, or we can write it as 200 into 10 raised to minus 3 or 0.2 kilograms. Mass of gun, let's write it by capital M. How much is that? It is 4 kg, so it's 4 kg. So now, so before that bullet ejects out of the gun, you have total momentum equal to 0. Okay, so you get the law of conservation of momentum, right? So your law of conservation of momentum gives you m1u1 plus m2u2 equals to m1v1 plus m2v2. Total momentum before that bullet is ejected, it's equal to 0. So final momentum should also be equal to 0. Okay, and what is m and v? So m1 is equal to small m, v1 is equal to what? It's velocity of the bullet. Okay, so I will write it as velocity of the bullet plus m2 is capital M, and v2 is velocity of the gun. Okay, so from here I can find out that mass of bullet into velocity of bullet is equal to, if I take this on the other side, it will become negative, minus of mass of the gun into velocity of gun. And now you can divide it by small m, so you get velocity of bullet is equal to what? Minus of mass of the gun divided by mass of bullet into velocity of the gun. Okay, this you can write. After that, what's given? The total kinetic energy is given. It is 1.05 kilojoules. Okay, kJ is kilojoules. That means it is 1.05 into 10 raised to 3 joules. Okay, so how much is total kinetic energy? So kinetic energy of bullet plus kinetic energy of gun is the total kinetic energy. It's 1.05 into 10 raised to 3 joules. This is given. So this will be what? Half of m into vb square, velocity of bullet square, plus half of capital M, this is mass of the bullet, sorry, mass of the gun, multiplied by velocity of gun square. This is equal to, what do we get? It is 1.05 into 10 raised to 3. Alright. Then we wanted to find out the speed of what? The bullet. Okay, the shell. Okay. So we can write velocity of gun in terms of velocity of bullet. So it will be the other way around. We'll take this m and capital M on the other side. So we get what? From here, v of g, velocity of the gun, is equal to minus m by capital M into velocity of bullet. Because we want to find out velocity of bullet, we'll remove, okay, velocity of gun from all the equations. Okay, so what do we get? We get half of capital M, the velocity of gun was small m upon capital M into velocity of bullet square. It is half of m into vb square. Okay, this is equal to this thing. All right, then what do we have? So squaring this, we'll get half of capital M into m square upon capital M square multiplied by vb square is half of m into vb square equals to this thing on the right hand side, and then we can take vb square common. So vb square will take common. What are we left with? We're left with half m multiplied by this m will get cancelled. Capital M will get cancelled with this one. So half m plus half of m square upon capital M. This is equal to this thing. And now we have to substitute the values. Okay. So somewhat lengthy problem, but it's okay. Let's substitute the values. So let's take 2 on the other side. So it will go into the multiplication. So 1.05 into 10 raised to 3, I will write as 1050. Okay, I will multiply out. So we have on right hand side 2 times. I have taken that 2. Okay, this 2 I have taken on other side. It will go in multiplication. 2 times 1050. Okay, this is vb square, velocity of bullet square, multiplied by, we are left with mass of bullet plus mass of bullet square divided by m. Okay, so how much is mass of bullet? Mass of bullet was 0.2. Mass of gun was 4. Let's substitute. So 0.2 plus what? 0.2 square divided by 4. Okay, So that is 0.2 plus, what is 0.2 square? It will be 0.04. 0.04 divided by 4. Okay, so 2 into 10 raised to minus 1, square of that will be 4 into 10 raised to minus 2. So lengthy. Okay, 1050 multiplied by 2 will be what? 2100. Alright, so this will give us 0.04 divided by 4 will be 0.01, and that's 0.2 was to 2100. Yeah, there will be some simplification, v square. Okay, so this gives us 0.21. So that's 2100, and now we can take that 0.21 on the other side. So it will be 2100 divided by 0.21 is VB square. So how much is that? It is 21 into 10 raised to minus 2. That we can take into numerator. So it will be 10 raised to plus 2. And this 21 will get cancelled out with this. And we are left with 10 raised to minus 2. Okay, or 0.01 you can say. You take that into numerator, it becomes 10 raised to plus 2. So 100 into 100 we have in numerator, and we want velocity of bullet, which is square root of that, and that is 100 meters per second, because this is what? 100 into 100. Okay, 100 square we have if we take this 10 raised to minus 2 in numerator, and we want square root of that. Alright, so velocity of bullet is 100. Yeah, so it matches with option C. So option C is the answer. Okay. Alright, let's move on to the next problem. And next problem is, the potential energy of a particle in a force field is given by this formula. Yeah, and good that this equation came, this question came. Okay, because in notes I have missed this topic. So let's cover this topic first. Okay, where A and B are positive constants and R is distance of particle from the center of the field. For stable equilibrium, the distance of particle is. Alright. Let's go back to notes. I will add one very small topic over here. Okay. So the small topic is relation between potential energy and conservative force. And what's the relation between them? So we need to memorize this. So if U is potential energy, then conservative force F is given by minus of derivative of this potential energy with respect to the distance. Okay. It is called as negative of gradient of potential energy. Okay. Derivative sorry. So derivative with respect to position is called gradient. All right. So yes. So we saw earlier that for a conservative force, what is potential energy? Potential energy is given by integration. It is work done against that conservative force. Okay. Potential energy is work done against the conservative force, and so if we want potential energy from force, what we do is, it is negative of, let's say Fc is the conservative force, integral of Fc dot dr. Okay, from some 0 to r. So this is basically one relation is in form of integral, and another relation is in form of derivatives. Okay, so or this is actually fundamental theorem of calculus, the relation between integral and derivative. Okay, so if you get u as minus of integral of fc dot dr, then what is the relation between fc and u? So fc will be equal to minus of du by dr. This is fundamental theorem of calculus. All right, so let's move on. This is how we find out the conservative force from potential energy. Till now we found potential energy from force. So now we will find force from potential energy. So let's go back to the problem. Yeah, here it was. Yes, the question is u is given by this formula and we have to find out the for stable equilibrium the distance of particle is. Okay, what should be distance of the particle for stable equilibrium? So stable equilibrium means force acting on particle should be how much? It should be 0, right? So we can write for stable equilibrium, force should be equal to 0. So this particle is under the action of a conservative force for which potential energy is given by this formula. Okay, so this should be equal to 0. That means what? How do we find the conservative force given the potential energy? So conservative force is minus of derivative of potential energy with respect to position. Okay, the distance. Okay, so minus of du by dr is 0, means du by dr is 0. So d by dr of this thing, a by r square minus b divided by r is equal to 0. Okay, or you can write it as d by dr of a times r raised to minus 2, because this is r raised to 2, I am taking it in numerator, it becomes r raised to minus 2 minus b times r raised to minus 1 is equal to 0. Okay, so r in denominator we have r raised to 1 over here. I'm taking it in numerator, so it becomes r raised to minus 1. So we have derivative of that is equal to 0. So it is a times derivative of this term r raised to minus 2. What will be that? d by dr of r raised to minus 2 minus b times d by dr of r raised to minus 1. This is equal to 0. So a times, I'll take this on the next page. A times d by dr of r raised to minus 2 minus b times d by dr of r raised to minus 1 is equal to 0. Then we know derivative d by dr of r raised to n. What is that? How do we find that? So it is n times r raised to n minus 1. Okay, so here n is equal to minus 2 and here n is equal to minus 1. Okay, so it is a into n times, that is minus 2 times r raised to n minus 1, that is minus 3. Minus 2 minus 1 is minus 3. Minus b into minus minus 1, because here we have r raised to minus 1. So minus 1 into r raised to minus 1 is minus 2, and that's equal to 0. Okay, so what do we get? So this r raised to minus 3, again I will write it as, I will take this minus on other side, the second term on other side. So it is minus 2a upon r raised to 3 equals to, I will write minus 1b upon r raised to 2. Okay, so what I have done is, I have taken this term on other side and I have also written r raised to minus 2 in denominator, which becomes r raised to plus 2. Okay, so what happens? This r raised to plus 2 gets cancelled out with this, and you are left with r over here. You can take that r on the other side. So this negative sign and negative sign gets cancelled, or you can say you are dividing minus 2 by minus 1, which becomes 2. Okay, so it is 2 times a equals to r into b. I'm taking this r on the other side. That means we get r equals to 2a divided by b. Okay, so the equilibrium is established at r equals to 2a divided by b. All right, so this is the answer. R equals to 2a divided by b is the answer. Okay, so it is simple. Any question? Yeah, any question in this problem? Guess no? Yes. Let's move on to the next problem. So next problem is the potential energy of a system increases if work done upon the system by a non-conservative force. Okay, if work is done upon the system by non-conservative force like friction, what will happen? The potential energy will, the energy will decrease, not increase. Okay, so this cannot be correct. Work done by the system against a conservative force. So if work is done against a conservative force, what happens? It gets stored as the potential energy of the system. So this answer is correct. This option is correct. Option B. Okay. Potential energy increases if work is done against the conservative force. This was simple. Let's move on to the next problem. A mass m is attached to a thin wire and whirled in a vertical circle. Okay, now we have question on vertical circle. The wire is most likely to break when? So the wire will break when the tension is maximum, and we have seen where is the tension maximum in vertical circular motion? At the lowest point. Okay, so there are chances that it will break, great chances that it will break at the lowest point when the mass is at the lowest point. Option D is the answer. Good. Let's move on to the next problem. A body initially at rest and sliding along a frictionless track from height h. It is sliding from this height h. Just completes a vertical circle of diameter AB equals to D. So diameter AB is equal to D. The height h is given is equal to. Okay, so how do we solve it? So we know that for vertical circular motion, what should happen? Velocity at this point A must be equal to what? It should move with minimum velocity there, which is square root of, so velocity at this point A, at the bottom point square root of pi gr. Okay, so in order to move in this vertical circle, it should at least achieve this much velocity, which is square root of pi gr. Okay, so if it is released from rest from this point, then we can say what will happen at this point? V square, Va square will be equal to, it is u square plus 2 times acceleration, okay, 2 times g into h, we can say, right? Okay, this is the law of conservation of energy. Okay, so potential energy plus kinetic energy at this point is equal to sum of potential plus kinetic energy at this point. At this point, what happens? Kinetic energy is 0. At this point or this point, the potential energy is 0. Okay, so you get this thing, or you can directly say that this is the second kinematic equation also. Okay, but speed at this point or this point will be equal. All right, so Va square, so it is released with 0 speed. So this first term is 0, and Va square, we want minimum what? Va equals to square root of pi gr, so that it will perform the circular motion, vertical circular motion over here. So Va square will be what? It is pi gr, and that's equal to 2 times g into h. So g don't need to substitute, it gets cancelled out. G and G gets cancelled out. We take 2 on the other side. Okay, so we get H equals to 5R divided by 2. Okay, and if we substitute diameter over here, because the relations are given in terms of diameter, so diameter equals to 2 times radius, so we have to multiply by 2 and divide by 2. It is 5 times 2R upon 2 times 2, and this 2R is equal to diameter. Okay, so that is H is equal to 5 divided by 4D. This is the answer. So option D is the answer. Okay. Yes, so this was very simple problem. Okay. Next question. What is minimum velocity with which a body of mass m must enter a vertical loop of radius r so that it can complete the loop? So this we have seen just now. Okay. What should be the minimum velocity with which this ball, okay, or this body enter at this point? It is square root of 5gr. Option B is the answer. Okay, so this kind of direct questions should be asked. All right. Next question. A block of mass m, capital M, is attached to lower end of a vertical spring. The spring is hung from ceiling and has force constant value K. The mass is released from rest with the spring initially unstretched. The maximum extension produced in the length of the spring will be. Okay, so this is the question. So what should be max? So what's happening here? A block of mass m is attached to lower end of a vertical spring. So we have a block of mass m, we have a spring, and block of mass m is attached over here. Okay, the spring is hung from ceiling and has force constant equal to K. The mass is released from rest. So if we release it from rest, what will happen? There will be some extension in the spring. Okay, so suppose this block goes like this, there will be a point where its speed is maximum. After that, it goes on decreasing. At some point, it becomes 0. Okay, and then it moves upwards. Again, its speed will become maximum at some point, and then it will move upwards and it will stop. Okay, again it will decrease. So speed increases, it becomes maximum at some point. Again, it goes back like this. Okay, so it goes like this, its speed decreases. So the distance, let's suppose distance of its path is this much. Okay, so its speed becomes maximum at this point. Okay, at this point. All right, and it becomes 0 at this point and this point. Okay, it performs oscillations like this. All right, so now how much will be the extension, maximum extension produced in the length of the spring? This is the question. So let's suppose when we hang that mass, what will happen? There will be some so when we hang that mass, okay, due to the weight of spring, it will get elongated. Okay, so elongation will be how much? It will be, suppose h is the elongation. Okay, so it will get balanced at some length. So when mg is equal to what? K times x, then the gravitational force and the spring force gets balanced, right? But there will be some potential energy to it at this point. So what happens? That total potential energy gets converted to spring energy. At that point, it will stop. Okay. right? There is some potential energy. When the total potential energy gets converted to the spring energy, at that point it will stop. Okay, so what I can say is there is some potential energy at this point, and that total potential energy gets converted to spring energy. Then distance is suppose this much. Let's call it what? I will call it h. Okay, so mgh will be equal to how much? It will be half of k into h square, you can say. Okay, because that much is the elongation, right? So you can cancel out this h with this square, and you can take 2k, sorry, this 2 and k on the other side. So what will you get? You will get what? H equals to 2 mg divided by k, right? So there are two things here. When will it get balanced? So the distance, if you want to find out the distance where the spring is balanced, okay, then spring force should be equal to what? Spring force is pulling that mass upwards. Gravitational force is pulling the mass downwards. Okay, so spring force equals to gravitational force is the distance when it will get balanced. But we don't have to find out that distance. We have to find what distance? The distance where the maximum extension. Okay, so as I explained, what will happen? This block will perform oscillations like this. Okay, so when it is released, it will move down because of gravitational force is attracting it. Its velocity will become maximum at some point. After that, again it will keep on going down, but its velocity will decrease. Why? Because there is spring force which is pulling it upwards. At some point it will stop. Okay, and from there it will start moving upwards. Okay, so this is that point where the speed is maximum. It is released from here. This block moves, okay, down. Then its velocity becomes maximum at this point. Then it moves further down. Again, it starts moving upwards. So it performs oscillation between these 2 points. Okay, so it is released from here. It moves till here. So what happens in between is its potential energy gets converted to the spring energy. Okay, because we are increasing extension in this spring. So that's how we solve this. The potential energy, change in potential energy is equal to what? The spring energy, half of k into x square. But how much is x? How much is displacement? It is h. All right. So then we get this value of h. Okay. So the answer is option A. It's not B. Okay, Dev. Yeah. Then let's move on to the next problem. A vertical spring with force constant K is fixed on a table. Then a ball of mass m at height h above the free upper end of the spring falls vertically on the spring so that the spring is compressed by a distance d. The net work done in this process is. So there is some ball which is released like this and it falls on the spring. Okay, then what happens? So this ball will move down. It is released from height h. So how much is work done by gravity? Okay, after that it is given, it approaches here, then the spring is compressed by distance d. Okay, so spring is compressed by distance d. So let's suppose it gets compressed up to this distance, like this. Okay, so what is work done due to gravity in this process? It is mg h plus d, right? It is mg h plus d. Mg h plus d is the work done, plus we have some work done against the spring. Okay, so there are two forces, one is gravity, one is spring force. Okay, and here work is being done against the spring force because spring force will try to push it upwards. but it is moving downwards. So by how much distance the spring is getting compressed? By distance d. So it is minus of half of kd square. Okay, so this should be the answer. So it is mg h plus b is the work done by the gravitational force, and minus of half of kd square is the work done by the spring force. So it is option A. Alright, this should be the answer. Change the time of the stream. What should be the time? Alright, let's see this problem. A body of mass 1 kg begins to move under the action of a time-dependent force where I and j are unit vectors. What power will be developed by the force at time t? This is the question. Okay, so there is this force, time-dependent force, and we have to find out what power will be developed at time t. Okay, so we know that the power is given by this formula. It is equal to force times velocity. Right, the formula for power is force times velocity, f bar dot v bar. So here we are given with force and we have to find out velocity. So how do we find velocity? Velocity, we can write acceleration is equal to dv by dt. Okay, and we are given with force. So what is acceleration? It is force upon mass. This can be written as dv by dt, right? So force is given, mass is 1 kg. So mass is 1, that means F is equal to dv by dt. We can take dt on the other side, so we get dv equals to F dt, and if we integrate this from 0 to v, because initial speed is 0, whatever is initial speed, u to v you can say, and then because body begins to move under this force, so initial speed is 0, and then on right hand side we'll have 0 to t. Okay, so now let's do this, let's integrate this. So what do we get? Initial speed is equal to 0. So integral of dv is v, upper limit is v, lower limit is 0. So it is v minus 0 or v. Integral of f dt. Okay, what is f? So f is given by this formula, 2t into I cap plus 3t square, 3t square into j cap. Oh, j cap. Okay, into we have dt. So now what will be integral of 2t, 2 times t? 2 we can take outside. Integral of t will be t square upon 2. So v is equal to this integral we are solving. 2 we can take outside. Integral of t will be what? T square divided by 2. So we have 2 times t square upon 2 into I cap, and then we have 3t square. So 3 we can take outside. It will be integral of t square. So integral of t square is t cube upon 3. So it is plus 3 times this plus sign in between. Yes, plus 3 into t cube upon 3 times j cap. Okay, this is the velocity. And this 2 and 2 gets cancelled. 3 and 3 gets cancelled. So we have t square I plus t cube into j cap. Okay, this is your velocity, v vector. Okay, and this is all vector. Huh? All right. So then we wanted to find out power. Power is the product of force and velocity. So let's find it out. What is force? Plus 2t I cap plus 3t square j cap. So this 2t into I cap plus 3 times t square into j cap, and we have t square into I cap plus t cube into j cap. Okay, this is power, this is force, this is velocity, right? Power is dot product of force and velocity. So 2t into t square, how much? I dot I is 1, 2t into t square is 2t cube, 2 times t cube, plus we have 3t square into t cube. So 3t raised to 2 plus 3. T square into t cube is t raised to 5. So 3t raised to 5. This is the answer. So 2t cube plus 3t raised to 5 is option B, and this is the answer. Okay. All right. So it's 10:14. I will skip. I will skip one or two questions. Okay. So let's see this question. A body projected vertically from Earth reaches height equal to Earth's radius before returning to the Earth. The power exerted by gravitational force is greatest. Where is the power exerted by gravitational force is greatest? So we know power is what? It is product of force times velocity. So if we consider that force is almost constant, where is the velocity maximum? Actually, if you release this body from here, it goes to the height r and it comes back. So gravitational force is also maximum at this point, okay, near to the earth, and velocity is also maximum at this point only. And power is what? It is product of force to velocity. Both are maximum at this point when it is released or when it reaches. Okay, so answer is at the height of position of the body, not this one, at the instant just before the body hits the earth. Okay, just before it hits the earth, what will happen? The force is also maximum and velocity is also maximum. Okay, so power is maximum when the body hits the earth, just before it hits the earth. All right, so this was simple problem. All right, let's see next problem. A body, a moving block having mass m collides with another stationary block having mass 4m. The lighter block comes to rest after collision. Lighter block comes to rest when the initial velocity of lighter block is v, then value of coefficient of restitution E will be. Okay, so question is, the lighter block comes to rest after the collision when the initial velocity of lighter block is v, then the value of coefficient of restitution will be. Okay, so see, initial velocity is given, so we can say m into u plus, or m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. Okay, so this term is 0 because initially this block of mass m, it collides with the stationary block of mass 4m. So it's stationary, that means its speed is 0. And after collision, what happens? The first block comes to rest. So this term is 0. So what do we have? So mass of first block is m. Its initial velocity is given to be v. Mass of second block is what? It is 4 times m. Let's substitute that. 4 times m. Its velocity is suppose v2. So how much will be v2? So v2 is equal to, okay, m gets cancelled and we take 4 on the other side. So we get, it is v upon 4. And what is coefficient of restitution? So E equals to v2 minus v1 divided by u1 minus u2 and here u2 and v1 are 0, v2 is equal to what? V upon 4, and u1 is equal to v. So v and v gets cancelled. Coefficient of restitution is 1 by 4, or you can say it is 0.25. Okay, so this is the answer. All right, so option B is the answer. This was a simple problem. Yeah, let's see next one. Two identical balls A and B having velocities 0.5 meters per second and 0.3 meters per second respectively collide elastically in one dimension. Okay, so there is elastic collision between these two balls. The velocities of B and A after the collision respectively will be. So these are, it's given that these are two identical balls. Okay, so if balls are identical, what happens? Their mass will be equal, and we have seen what happens to the bodies of equal mass in elastic collision. Their speeds get exchanged, right? So what will happen? The speeds will get exchanged. So speed of first one will become -3 and speed of second will become 0.5. So which is the option? It is -3, 0.5 is option C. In case of elastic collision, if the two bodies have equal masses, then what happens? Their speeds get exchanged, the velocities get exchanged. Okay, so option C is the answer. It was very simple. Let's see another problem. Two particles A and B move with constant velocities v1 and v2. At initial moment, their position vectors are r1 bar and r2 bar. The condition for particles A and B for their collision is, okay, so we have two particles or two objects. This is r2, this is at position suppose r1 bar, r1 bar. Okay, now they are moving with velocities. Let's consider one dimensional case for simplicity, v1 and v2. Okay, so what is the relative distance between these two? Relative displacement to be covered by the first object. It is r2 bar minus r1 bar. Okay, this object has to move. This object has to displace relative to the second object with this much displacement, and this is r2 bar minus r1 bar. So let's suppose it happens in some time t. So how much is relative velocity of first with respect to second? So relative velocity, I can write that v12 bar is relative velocity of first with respect to second. So it is velocity of first minus velocity of second, right? So if there is no acceleration, then the relative displacement to be covered will be equal to what? Relative velocity multiplied by time, right? So at some time t, let's suppose they collide. So suppose they collide at time t, then relative displacement will be equal to relative velocity. Relative displacement will be relative velocity multiplied by time. So that is, what is relative displacement to be covered by first body? It is r2 bar minus r1 bar. It is equal to relative velocity is v1 bar minus v2 bar multiplied by t. Okay. After that, what I can say, so t is some number. So if these two vectors r2 bar minus r1 bar can be written as some number multiplied by v2 bar minus v1 bar minus v2 bar, then which of these options would be correct? So let's check the options. Okay, r1 cross v1 equals to r2 cross v2. Okay, Second one is R1 minus R2 equals to V1 minus V2. So what we can say is second is not correct. This will be correct. No, this is not correct at all. R1 dot V1 equals to R2 dot V2. Okay, so we cannot verify these options, but if you look at this one, okay, this is unit vector in direction of R1 minus R2. This is unit vector in direction of V2 minus V1. So here we can write, if I take negative of this, if I take negative of this equation, I will write, if you look at this, it was R2 minus R1. I will take negative of that, it will be R1 bar minus R2 bar. It will be equal to, the negative of this term will be V2 minus V1. What I have done is I have just taken minus sign common. So V2 minus V1 multiplied by T. So if these are two vectors, okay, and one vector can be written as some other vector multiplied by some multiplicative factor, some number, then they are in same direction. That means their unit vectors must be identical. So what we can say is unit vector for this one is the vector divided by its magnitude will be equal to unit vector for this one. Okay, see, these two vectors can be written as, this is my R1 bar minus R2 bar. Okay, this full vector is R1 bar minus R2 bar, and this much is suppose V2 bar minus V1 bar. And I am writing this vector R1 bar minus R2 bar, which is from here to here, as some number multiplied by this vector. Okay, which vector? This vector, which is V2 bar minus V1 bar. Okay, R1 bar minus R2 bar, which is this much, is equal to some number, just some number, not any vector, just some number, which is T, into V2 bar minus V1 bar is a vector from here to here. Okay, so for these two vectors, what the unit vector should be in same direction. That's what I am writing. So unit vector for R1 bar minus R2 bar is equal to unit vector for the second one, V2 bar minus V1 bar divided by its magnitude, V2 bar minus V1 bar. Okay, these are unit vectors. Unit vectors are equal. Okay, and that's why option C would be the answer. Okay, yes. So let's see another problem. A ball thrown vertically downwards from height 20 meters with initial velocity v0 collides with the ground, loses 50% of its energy in collision and rebounds to the same height. Okay, the initial velocity v0 is all right. Let I'm sorry. Let's suppose the ball collides with some velocity. Okay, suppose ball collides with the ground with velocity v. So what we can say, it is released with initial velocity v0. Okay, so can we say v square equals to v0 square plus 2gh. Okay, so ball is released from the side with velocity v0. It collides to the ground with some velocity v. So final velocity square equals to initial velocity square plus 2 times of g into h, right? Okay, then what we can say, okay, it loses what? Half of its kinetic energy. It loses half of its kinetic energy and it reaches the same height. So v is its velocity. What will be its kinetic energy? kinetic energy when it reaches the ground is half of m into v square, and it rebounds with half of the kinetic energy. So kinetic energy when it goes up equals to what? Half of the kinetic energy with which it falls. So then it reaches the height h. Okay, then it reaches the same height h. So what we can say, that kinetic energy at the bottom, okay, at the ground, is equal to potential energy at top, right? So how much is kinetic energy with which it rebounds? It's half of the kinetic energy with which it falls. Okay, so this half of kinetic energy at the ground, okay, it will be equal to the potential energy at height h. So it is equal to potential energy at height h. Okay, because it goes to that height and it is rebounding with how much kinetic energy? Half of the kinetic energy with which it falls. Some energy is lost. So how much is kinetic energy left to the ball? Half of the kinetic energy. Okay, that's its total energy at the ground when it rebounds. Okay, so that total energy will be equal to what? Potential energy at height h. Okay, so half of, you can say half of mv square equals to mgh, that you can write, and then we have v square equals to this thing, v naught square plus 2gh. Let's substitute that. So half of half is 1/4. Okay, so we have 1/4 of m into v square, which is v naught square plus 2gh equals to what? Mgh. Mvh, so m gets cancelled out. We can take 4 on the other side, so it goes into multiplication. It is 4gh. So v naught square plus 2gh is equal to 4gh. Take 2gh on other side. So v naught square equals to what? 2gh. 4gh minus 2gh. So v naught equals to square root of 2gh. Okay, let's substitute value. G equals to 10 and h is equal to 20. So it is 2 times 10 into 20. So 20 times 2 is 40, 40 times 10 is 400. Square root of that is 20 meters per second. Okay, so this is the answer. 20 meters per second is the answer. All right. So is there any question? No questions. So we'll stop at this point. Okay, and tomorrow we'll talk about next chapter. We'll talk about gravitation. Okay, so let us stop here. So thanks for watching the lecture. Bye.